Happy Wednesday, class. I want to apologize. I didn't get a chance to really watch the video until after I posted it. I did not really realize that Tuesday's video was going in and out. So I'm going to try my best to make sure that today's video is recording well. I'm still trying to figure out why some of the videos are going in and out at certain times, whereas other ones are working just fine. So what I'm probably going to do is, this is probably the last video I make for this week at this moment until I can figure out why the other ones are going really awry. If I'm able to figure it out, I'll post up 2 more videos by Thursday and Friday. So today's lesson. I'm sorry, we're already on slide 2. We're supposed to be on slide 1. Is lesson 16, population problems. So we're going to be working on population problems. Now, normally population should be tied into statistics, but we're throwing it in with percents early because you need to go ahead and start getting this this feel for what statistics may look like. Population-based problems are basically, you're looking at a small representation of a whole. So this class would be a small representation of the whole school. This would be a population. All right, the school would be considered a community. So this class is just a population. So we're going to answer some problems that are related to population. Now you have to be patient with me. These are kind of new steps for me too. So we're going to work on these together, and we're going to come up with the same conclusion to give us the same answers at the end. Now, the first opening exercise is actually pretty easy. This is just, we're going to make up some information here because, well, we don't have a class. We actually have nobody here to be able to actually take this information and work with it. And this information would change class to class because each class has a different number of students. So we're just going to run a basic scenario, a pretend situation. Okay? So let's say the number of girls in the classroom is 12. We have 12 girls in the classroom. All right, the number of boys in the classroom, we're going to say there's 13. So how many total number of students are in the classroom? Well, that's 25. That's 25 students in the classroom. So the percent of the total number of students that are girls, well, percent, if you remember, is a fraction. It's 12 over 25, and we're going to multiply that by 4 over 4, which gives us 48 out of 100. That means there's 48% of the class is girls. So that means what percent of the number of students would be boys? Right, it would be 52%. Because this and this have to add up to give us what? Right, 100%. Okay? Now, here's where things get a little interesting. So now we're looking at the number of girls whose names start with a vowel. Well, not every girl in the classroom starts with a vowel, does it? We don't have somebody named that Alicia or April or Olive or Erica in the classroom. Not every one of us starts with a vowel. Now remember, vowels are A, E, I, O, and U. Okay? So we're going to say that only 4 students in the classroom have a name that starts with a vowel. The boys, we only have 2. Okay? Eric and Evan. All right, so the total number of students whose names start with a vowel, well, that's 6. So let's go back. The percent of girls whose names start with a vowel. Now, are we talking about the percent of girls in the whole class that start with a vowel? No, we're talking about a percent of just the girls. How many girls are in the classroom? So that means 4 girls out of 12 have a name that starts with a vowel, which reduces to 1/3, or we're going to say 33%. So 33% have a name that starts with a vowel out of just the girls. Now, the percent of boys whose names start with a vowel. Well, remember, there's 13 boys. So that's 2 out of 13, which gives me, and even Mr. Hale does not know this one off the top of his head, 2 divided by 13 gives me, all right, we're going to round up, 15%. So 15% of the boys have a name that starts with a vowel. Now, are we saying 15% of all the kids in the classroom have a vowel? No, we're only saying 15% of the boys. The boys only represent 13 of the kids. So technically, we're only looking at 2 out of 13 boys. Now, if we were saying 6 out of 25, that would be a different story. But we're only asking for the percent of the boys, not the percent of the total number of students. So you got to be very careful about what it's asking you. All right, so last three questions. The percent of the total number of students who are girls whose names start with a vowel. So the percent of the total number of students who are girls whose names start with a vowel. Okay, so the percentage of total number of students was what? 25. Out of that 25, 4 had a name that started with a vowel. So 4 out of 25, which would be 16%. 16% of the population starts with a vowel for girls. Now the boys, that's 2 out of 25, which gives me what? 8%. So the percentage of the total number of students whose names start with a vowel, well, that's going to be 6 out of 25, or that's going to be 24%. So if you notice, if you take this percent and this percent, add them together, you get the total percent. That's going to come in handy because the next few problems are all going to be working off of that type of percentage problems, those type of population problems. You're going to need to understand how the whole can be broken down into the individual. All right, so let's go ahead and get started. As you can see, there's only 7 slides. The first slide was the introduction slide. The last slide is your homework, so that's 2 slides out. That's only 5 total slides. So we're going to be working on this pretty quick. So a school has 60% girls and 40% boys. If 20% of the girls wear glasses and 40% of the boys wear glasses, what percent of all students wear glasses? All right, now, normally I would sit here and try to teach you an equation, but an equation is a little bit tougher to work on. All right, I know how to find this answer and I know how to find it quick, but the problem is I know you don't. So I'm going to teach you using tape diagrams. Well, Mr. Hale, why are we using tape diagrams? Because tape diagrams are actually a decent representation of what it is we're trying to find. So, tape diagram. We're going to start off with just a simple tape diagram. It's not going to be pretty, and it doesn't need to be pretty. Okay, so 60% are girls. Okay, so 60% of girls. We're going to represent that with 0.6n. And then this is going to be 40% of boys, which we're going to represent with 0.4n. And then this whole thing here is going to represent 100%. So think about it. All I've done is take a 100% tape diagram and I've broken it up into 2 individual sections based off the information that was provided to me here. Okay? Now, the next part. If 20% of the girls wear glasses and 40% of the boys wear glasses, what percent of all students wear glasses? So we're going to need to create a second set of tape diagrams. Okay? So the total number of girls wearing glasses is basically as follows. Okay? So it's like this, okay? We're talking about 20% of 60% wear glasses. And we're talking about 40% of 40% wear glasses. Now, what are you talking about, Mr. Hale? Okay, so 60% represent girls, 40% represent boys. So 20% of the girls, well, the girls represent 60%. So 20% of the girls, 60% of the girls wear glasses, whereas the 40% represents the boys. 40% of that 40% wear glasses. So how do we come up with our answer? Well, it's a multiplication problem. Remember, the word of means multiplication. So it's 0.2 times 0.6, which gives us 0.12, and we're going to use the letters N here as well. So these are going to be N's. Okay, so we get 0.12N. 40% of 40% wear glasses. So that's going to be 0.4 times 0.4, which gives me 0.16N again. So now let's put this together. Okay, so this is the number of girls that wear glasses. This is the number of boys that wear glasses. So what's the total number of students that wear glasses? Well, that's going to be 0.12N plus 0.16N, which gives me 0.28N. Now, you're asking, Mr. Hale, how do I know how many students wear glasses then? Well, remember, okay, if you go back and look at the very beginning, we said 60% is representative of 0.6n. So that means 60% of the 100% represented by 0.6. 40% represented for n, 0.4n. So if these two numbers can combine, they would give me back to 100%. Okay, I would basically take n, and we're going to say n represents 100. So if I took 0.28 and multiplied it by 100, what would I get? I would get 28%. So that's the number of students that wear glasses. 28% of the entire class population wears glasses. That's how you find it. Okay? I know you're looking at that like you're completely and utterly confused. Well, let's try it again, okay? Exercise 1 gives us the same information, but it kind of flips it around on us. So it gives us a second chance to be able to work the exact same problem. So we're going to do it again. Okay. Let's see. Yes, perfect. So let's draw a shape, shall we? Is it going to draw a shape? No, it's not going to draw a shape for me. Let's put the pen away. There we go. Well, not exactly what I was looking for. Let's try it again, shall we? Let's see again. Shape. Let's look for, there we go. Rectangles. Rectangles always are better. There we go. Now we got a rectangle. All right. Let's get back to the fun stuff. Okay. So how does the percent of students who wear glasses change if the percent of boys and girls remains the same? That is, 60% are girls, 40% are boys, but this time 20% of the boys wear glasses and 40% of the girls wear glasses. So we still got the exact same situation. We still have a tape diagram that represents 100%. But this time we have 60% that are still girls. We still have 40% that are boys. Now I need to represent these numbers as decimals. Well, 60% can be represented by 0.6, and we're going to multiply it by n. Okay, because remember, we're going to say n is when you take an n, it's being multiplied by 100. So we're going to say n represents 100. Okay, so 40% is going to be 0.4n. Now, what's changed? Well, this time it's 20% of the boys that wear glasses and 40% of the girls that wear glasses. So this time we're saying 40% of the 60% of girls that are in the classroom wear glasses. And then we're saying that 20% of the boys, and 20% the boys represent 40% of the class, so 20% of that 40%. So 20% of 40% of the boys wear glasses, and we're just going to say WG. So this becomes, like I said, a multiplication problem again. So 0.4 times 0.6 gives me 0.24n. Okay, and then we got 0.2 times 0.4 equals 0.8n. I'm sorry. Oh, my bad. I made a mistake. Let's change this real quick. Okay, 0.08n. Okay, so now I got to come and I got to add the two together. So 0.24n plus 0.08n gives me 0.32n. And so what's the percent? Right, we're going to take 0.32 and we're going to multiply it by 100, and we get 32%. So has the number changed? Yes, it has. Okay. If the number of students in the classroom do not change, but the percentage of the students who wear glasses change, then we've got a different number of students that wear glasses. All right, so we always got to pay attention to what the question's asking us, and we got to make sure we pay attention to the problem. We can't always sit there and be assuming that everything's going to work out to where it's the exact same answer every single time. It's not the way it's going to work. All right, so how would the percent of students who wear glasses change if the percent of girls is 40% and the percent of boys is 60%? So normally I would say let's draw a tape diagram, but we really don't need a tape diagram because the information is still being consistent. So we're saying 60% are boys. So if I was to write that as a decimal, it would be 0.6n, and that means 40% are girls, which means that would be 0.4n. Okay, so how would the percent of students who wear glasses change if the percent of girls is 40% of the school and the percent of boys is 60%? And this time, 40% of the girls wear glasses and 20% of the boys wear glasses. So we got to go back to our multiplication again. So 40% of the girls, well, this time the girls are only representing 40% of the population. So 40% of 40% is going to represent 0.4 times 0.4, which gives me 0.16n. And this time it's 20% of the boys, which is 60%. So 20% of 60% is going to give me 0.2 times 0.6, which is 0.12n. Now if I add those two together, 0.16n plus 0.12n, I get 0.28n. And what do we say n represented every time? Right, it represents 100. So 0.28 times n would be 28%. So it would be 28% of the students who wear glasses. Now, that goes back to being matching the exact same as example number 1. That was 28% of the students that wear glasses as well. So what they're saying is that if the populations didn't change, this time the populations did change. So what happened? What was different from problem 1 versus problem 2? Well, problem 1 said that the school has 60% girls and 40% boys. So those two numbers switched. If 20% of the girls wear glasses and 40% of the boys wear glasses, okay, so it was asking 40% of the boys. So those numbers switched as well. So what this is being compared to is if the percentage of the population changes and the percentage of the individual populations changes as well, then we should get roughly the same answer every single time. But that's just a theory. Always do your work, always be certain, because theories are only good in your mind. They have to be proven. You always have to prove something. All right. So let's get down to this last problem, because this last problem looks like it's going to be, or not the last one, but this problem on the board here. All right. So the weight of the first of 3 containers is 12% more than the second, and the third container, is 20% lighter than the second. By what percent is the first container heavier than the third container? All right, so this looks like we're going to end up having to use tape diagrams again. Now, I like tape diagrams because tape diagrams do get us down to what we need to know. Okay, so we're going to sit there and take that, and let's copy it. Copy, paste. There we go. There's our second container. Let's copy. Let's paste again. All right, and there's our third container. So we got 3 containers. All right, now I think we should go with blue this time. I think blue is going to be a good color. So we're going to say this is the, let's see, this is the second container. We're going to make this one represent the second container. This is going to be broken up into 1, 2, 3, 4, 5 individual sections, but this still is going to represent 100%. So each of these is going to be broken up into 5 individual pieces. Okay? Now, I like the idea of 5, and you will see why 5 is the better choice here, okay? Now, the weight of the first container is 12% heavier. So we got our 100%, but then our 12% heavier. Okay? And then the weight of the third container is 20% lighter. So basically the weight of the third container is these 4 sections here, and this one here is no longer here. So what's the percentage there? Right, it'd be 80%. All right. I kind of got tired of seeing that little outline, guys. Sorry. All right. So this represents 100% or 1. This represents, which would be 1.12. This represents 100% minus 20%, which would be 80%. So now the question asks, how much heavier is the first container compared to the third container? Well, this becomes a very interesting situation here. Okay? So let's write that 0.80. My bad. So we've got 1.12 times n, 0.80 times n. So how much heavier is the first container versus the third container? Well, the question pretty much tells you what you're doing. How much heavier is the first container compared to the third container? That's a subtraction problem. 1.12 minus 0.80, which gives you 0.32 n. It's 32% heavier. Okay? All right. Oh, so we're not done. My bad. We're actually not done because the first container is not 32% heavier. Okay? You got to recall that the weight of the third container is 0.8 n. So this actually becomes a division problem next. Okay? So we're actually taking this information here and we're dividing it by this information here. So 0.32 divided by 0.80 actually gives you an answer of 0.4. So that means that comparatively, the first container is 40% heavier than the third container. So that's your answer. The first container is 40% heavier than the third. All right, let's move on. Almost there, guys. All right, so Matthew's pet dog is 7% heavier than Harrison's pet dog, and Janice's pet dog is 20% lighter than Harrison's. By what percent is Matthew's dog heavier than Janice's? So let's have H represent Harrison's dog. Okay? So Matt's dog is 7% heavier, or it's 1.07 times heavier. And Janice's dog is 20% lighter than Harrison's, or 80% or 0.8 times bigger. Okay? Now, we got a division problem. This is basically where a division comes into play. So what we're going to do is we want to know how much bigger Matt's dog is compared to Janice's. So we're going to take 1.07 and we're going to divide that by 0.8. Now, if we just multiply this by 100 real quick, we could just take 107 divided by 80, which gives us 1.3375. So basically, Matt's dog is 33.75% larger than Janice's dog. That's it. All right. I'm going to, let's see what's question 6 real quick. We're going to leave. All right, so we're going to make this question here, exercise 4. I'm going to make this a bonus again, because I think this is an opportunity for y'all to get some extra points, because I know I'm trying to get y'all an opportunity to get in pre-brigade. So if you can get question 4 right, I'll give you a bonus of 30 points. If you don't do question 4, then it's not going to penalize against you. All right, but this is a bonus. Why not get the extra credit? Why not get the extra points? All right. So your homework. Once you do the problem set for lesson 16, numbers 1 through 9. All right, it's not that hard of a problem. You're using the same steps, same process as everything that's been going on in the video. The reason why I'm recording these videos is for you to be able to go back and look at the information. Go back and see what it is you're struggling with. Why did Mr. Hale do this? Why did Mr. Hale do that? Take advantage of these opportunities. Do not sit there and just watch the video and guess. That doesn't do you any good. All right. So like I said, I'm going to check this video again. I'm going to make sure that there's no skips. If there's no skips, then we're going to move on to the next lesson. But if there is some skipping, I'm going to pause, probably come back and make some videos later on.